Hello, welcome back to Astronoscope Workshop. My name's Rue. Um, this is the next part in my spectroscopic slit project. The slit that I'm making, the adjustable slit, which is here, I need to get it mounted into the actual into a container so that I can actually use it with a telescope so that I can test the blades themselves. The blades I haven't finished yet, but as you know, this is a test, basically a test platform for these blades and for the adjuster mechanism as well. I haven't done anything with the slit for ages and ages and ages, and simply because I've been doing other projects for other people, and obviously pretty much those always get priority. Bits and pieces for around the house, my wife, they always get priority, obviously, and other people. In fact, I've got a whole bunch of parts I've made here for someone's telescope, which I've just got through making, so there's a whole bunch of those down there. You can probably see them in the corner of the shot. My spectroscope slate. Oh, the other thing I did is I bought a nice piece of stainless steel at the Auto Jumble last weekend, but it's sort of mystery metal, really. That I said to the guy, "Is it machinable?" And he said, "I've no idea." But then when I looked on the end, it's got machining marks on it, so I thought, well, there's a good chance it is. So I need it for some counterweights. I'm making a counterweight system for a guy's telescope, so these will make really nice counterweights just for doing some dynamic balancing on a Celestron telescope. So that weighs about 1.25 kilos, something like that. So it's a reasonable lump of stainless. But I just stuck it in the lathe and faced it and just sort of turned it a little bit just to see what it's like, and it does turn nicely. I managed to find some carbide tips which do specifically for stainless steel, and they work very well. Apart from the fact that as I touched off with the tip, the end just went ping and it flew off. So it's obviously very hard. So I had to do the old the touch off trick, which I learnt quite recently from a mate at the Auto Jumble, who was an experienced machinist, and he said when you're using ceramic tips, this is a technique you have to use. If you touch off with a ceramic tip onto something hard like stainless like this, he said you'll just trash it every time. So what they do is just get a piece of fag paper and approach with the tool, and when the fag paper drops through, you're sort of a thou away, and then you just put a cut on, and then you go in. As long as you've got a cut on, it's fine. But if you just touch the end of a ceramic tip or one of these, I've got these, as I say, specifically for stainless steel, so they're obviously really hard. They just snap the ends off. So I learned that lesson. So I did the paper trick on it after that, and it was fine. And you just got to make sure you've got a cut on. You can't piddle around with little diddy cuts, really. So I've got that to do later on today. So I thought I'd do a little bit on my spectroscope system. So this is the chap here. That's the actual adjustable spectroscope module, and it goes inside this holder here. Now this holder here I've half made. It already takes. This is the collimator for the spectroscope, which is a 25mm eyepiece, standard 25mm telescope eyepiece. So I made this case with an 1.25 hole in there, which is threaded the same as eyepiece barrels are threaded. I can't remember what it is off the top of my head, but that threads into there like that. So that is the collimating lens for the spectroscope. So in fact, I'm going to have a mount on the end of there with the actual grating in at that point there. So this is the sky end. And for that, in the last video, you'll remember that I made this collet here, and this is to hold. I made the barrel ages ago, and then I realised that I needed to do some more second work on this, so I had to make the collet, which is there to hold this, so I didn't mar it up, because I'd already done a finishing cut on there, stupidly as well. So rather than waste the whole work, I made the collet. So what I've got to do now is make a disc that goes in there, and I'm going to thread that centerpiece there. And the reason for that is that I want to be able to unscrew that to get at the spectroscope which is inside, because what I want to be able to do is unmount these blades here and change them, or take them out, polish them, put them back in and test them. So I just wanted this to, if I unscrew this boss I can get at the spectroscope slits quite easily without having to dismantle the whole thing, or, well, only half dismantle it, I suppose. So what we're doing here is going to make an end plate like this other one, and I've found, lost it already, where is it? Here it is. I found this lump of alley, which is a drop which I must have bought at the Auto Jumble, and I've never used it because it's still got chop saw marks on it, but it's exactly the same diameter as that. So I've just got to stick the outside jaws on in the lathe and just turn this down just to make it round and nice, and then part off, or in fact drill and tap for the centre, and then part it all off with a very long parting tool. See how that one goes, but over to the lathe. Right, as you can see, these jaws here aren't going to open up far enough to hold this, so we're going to have to put the outside jaws on instead, which means taking these ones off. Now they're numbered, obviously, 1, 2 and 3, so 3 will come out first. So if I unwind these, nearly there. Full of aluminium chips, which doesn't really help. Right, that's 3 out. So we go to 2, which is, that's 2, so, no it can't be. That's 1, that's 2, it's just 2. Well, the reason why this is taking longer is because my number 3 jaw has one of the teeth missing off it. That's why I had to wind around a whole revolution before I got there. That's how they came. It's never been a problem because I never use them really near the end. I mean, I try not to anyway. I always change them if they're close to the end, well, for obvious reasons. So that's the 3 out. So let's get this set here. So this one is 2, 1, so this is 1 here. There's a lot of crap in there, isn't there? Let's just clear that out. Could do with some air on the job, but I've not got my compressor on, so I'll just wipe it with this. Not too bad, actually. Right, so let's just check. That is 1, isn't it? Yeah, that's 1. So that one was 1, was it? What was that? 2. That's 2. That's 1. Oh, that's 1. There we go. So of course this is the other way on, so it goes in that way. So I'll just get the. If you look down in the scroll, you can see the start of the scroll. So put that in there, give that a turn, and that's now in. So we now go to 2, which is this one here. So this is my number 2. Just double check. Yep, that's 2. So that goes in here again. You can turn it until you see the scroll. The start of the scroll, which is there. A couple of turns, that's engaged, so we go up to number 3. Same thing here, just double check. Yes, that's number 3. Clean all the chips out. Wind it round until we see the start of the scroll. In she goes. Alright, there we are. So I can wind that in. Bloody chips everywhere. Right, I don't think that one. It might do. The outer one might do it. No, I don't think it will actually. I think this is, no, so it's going to have to be the next one down. So it won't fit in this one, it'll have to fit in this one. There we go. There we are. Give that a little tap. Tappity tap. Make sure that's up against the top. Tighten that down. Right, so I'm just going to face that. Just basically face, get something showing on there, and then drill, thread, etc. Let's just changing the tip for one specifically for stainless, which is one of these highly polished, honed and polished ground. I think that's what they call them. Ground tips, which are specifically for aluminium. Got you can see quite a lot of rake on them, and the sharpest a sharp thing, and you get a much nicer finish on alley with them. Let me just turn you around. Let me just turn you around to here so that you can see what's going on. Right, so let's get this faced off. Let's dial in a reasonable speed. So 1200 should do it. Right, that's a nice finish. So we'll just get rid of these stringy things. Now we'll just take a couple of mil off the outside just to clean it up. Righty ho. Can you see there? Let's get you in over here there. Nicer view for you there. Okay. Cleaned up, no it's not, need a bit more. Have a couple of foul. Right, that looks pretty nice. I might now we need to just turn that down now. Let's get a shoulder turning down to fit inside the tube. That's the shoulder that's going in there. It doesn't have to be as long as that, I suppose, but that's 300. So maybe I should make it 200, and it'll screw right through. It'll be a reasonably decent mount then, because that's the bit that's got to be hold solid to the telescope. So I'll make that 200 thou. Okay. So the way I'm going to do that is just using the, if you can see that from where you are, probably not, let me just move you here. To do that is if I just lightly touch up against that face and I move this in till it's reading, put it to 0, okay, just back that out now, and all I need to do now is move this into 100, so that's 25, that's 50, so if I go 25, 50, 75, 100, that's 100 thou on there, so I need to do that again, 25, 50, 75, 100, so that's 100 thou on that shoulder there. So what I do now is I just pull that back and then I just put some tension on there and I put 0, let's get it positioned correctly, and put 0 on there. So that 0 now is the stop basically. So I just come up every time when I see that, I just stop at 0 and just do that shoulder down to 3.365, which is written on my board so I don't forget it. So let's start cutting. We'll just touch off. Okay, I'll put a cut on just to get cutting. Go in until we see, there we go, we're on the dial, and we take it over to 0 and then we come out, and let's just have a quick check of that. Okay, that all looks fine and dandy. Let me just do a quick measurement of this just to see where we're at, and then we can get some dials set possibly. Get on that edge there, get on that edge there, okay. So we have got 347, 3, 4, 7, 2. Need 200 thou off. So I'm just going to zero that dial, and let's go cutting. Just touch the shoulder and then wind out like that just to clean it up. That should leave us with, there we go, and a nice shoulder on there. Yep, little lip, but that's no big deal. I can just run a deburr around that. So I'm just going to just break this edge, and then we can part the whole thing off. Actually, we're not going to part it off yet. We've got to drill and thread it yet, haven't we? So let me just change that for chamfer tool. That's all nice. So all ready for parting, and next job's to drill it. Alright, let's just get a start in there. Okay, got to start on. About 25 odd times, as I say, no great rush. And it stops the ball getting really hot. So, out the window. I'm just going to go and have a measure there. Can you see these? Look, you're right up inside the tube. I'm just going to do a quick measure with the old, see where we're at with that. We're a mile off yet. That's got the end of the case done, so we've got the nose piece now fitted to the plate, and that's secured onto the actual body of the spectroscope housing. So the this back plate here, which has the is going to have the actual spectroscope slit. This is the mechanism here mounted on it. Now, what I realise is that this has these two pieces here need to be fixed to this. And I was concerned about getting it centered correctly, and you've either got to mount it really accurately and make sure it's absolutely perfect, or make it adjustable. So I've decided to make it adjustable. Now what I've come up with is this. I've actually made this bit already because I'd forgotten to record this, but I just made this bit this morning, which is like a little sled for the spectroscope to sit in. So it's basically a piece of a bar which squared up, and then I cut this slot in. So the actual spectroscope slits quite, at the moment you can see it's quite sloppy in there, but the idea is I'm going to have 2 screws on each side at one end and 2 screws at the other, and so and those are going to pinch this mechanism itself between them. So I'll be able to adjust these push-pull screws at either end, and I'll be able to adjust left, right. I can slide it up and down, and I can twist it side to side as well. So that should give me all the adjustment that I need to get it centered. So that piece will be centered on here. So there's a hole in and we'll center that as best we can, and that'll be screwed down onto there, so that'll be solid. And then this will sit in there, and I can move this around and get it centered with these pinch screws that are on the side. I'm hoping to be able to make it so that I'll put some holes in the case here to line up with these screws, so that I can adjust those screws when it's actually mounted on the telescope, so we can use a laser or something to get it centered. And that's the plan. So all I've got to do now is I'm going to be using these M3 screws here, which will take me almost to the edge. Let me just put them on here so you can see. So if I put that on there like that, those screws here will come quite close to the edge of the tube, so I'll be able to get an Allen key in there to adjust them. So 4 of these in, and they're going in here. So I've worked out the dimensions, I've got them down here, so I've just got to go over to the milling machine and drill and tap these for M3. So what I'm going to do here is just get this wiped out here. Actually, it's still full of crapola in there. We'll clean that out in a mo. And what we need to do is get some parallels in there and get that sort of standing up about there like that. So the parallels need to be around about that. I think this is my finger. So probably those. So let me just clean that with my finger. Often best to wipe the jaws with your finger because you can feel small chips with your finger, and I find that's about right there. That'll be fine. Parallel. I'll take that one out now. It's just on the one parallel there, so I'm just going to. That's not a good thing to do. It's down on there anyway, so just nip it up a bit more. Make sure that's down on the parallel, which it is. So that's going to be enough. I'm only going to be drilling into here lightly, so it should be absolutely fine. So what we need to do is from the end, it's going to be 380 thou from the end, and from this front edge here, it's going to be 78 thou to where I drill my 2.5mm hole. So first things first, let's spot a hole. This is right through. Now, what we need to do is get that centered, and then this is the sled, and that needs to be centered over that hole as well, and then we need to drill the mounting holes through here, right through both, so that we can mount this on here. Now, I pondered for a while about how to do this, and then of course I thought of my mini pallet. I can't speak highly enough of these mini pallets. Yeah, okay, it took me a few hours to make it. There's a lot of holes and a lot of tapping, and it's a great way of learning how to do power drilling and power tapping on your Bridgeport. If you've never done much, by the time you get to the end of this, you're pretty good at it. I use this all the time. It's fantastic. It really is a great invention. What I've done is these two aren't clamped. This is the only one at the moment clamping this disc down. So what I'm going to do is going to centre that. So I'm going to use my clock holder like this, and I'm going to use my TTI down here. Let me just get this into the position, and what we're going to do is we're going to centre. We're going to centre this hole. Where am I going? Completely wrong direction. I'm going to centre this hole. Be careful not to crash that. Centre over this hole using this gauge. And once I've got that centred, then I'm going to introduce the sled, and I'm going to clamp the sled down from the sides, and we're going to centre that. So both of those will be then. Right, that's centred. Okay, that's zero all the way around now, so that's centered. Okay, so yep, that's zero, that's zero, that's zero, that's zero, so that's in the middle as well. Right, let's pull it out. So I just need to tighten those up. I hope that didn't move. I suppose I could just do a quick sweep again. That's all held down nice and tightly. Let me just going. That looks about right. Right, so I'm just going to drill right through with the